In this video, we're going to use the determinant of a 2 by 2 matrix to solve for unknown variables found in a matrix. So just a quick review. We did this in a previous video, which you can find in the description below. Just a quick review. If we have a matrix A, and it's a square matrix that has 2 rows and 2 columns, so it's a 2 by 2 matrix, the determinant represented like this be equal to A times D minus B times C. So I like to call that a crisscross. A times D minus B times C. Whatever value you get here is the determinant of A. Now, the determinant of a matrix can make the matrix be considered singular or non-singular. So the question is, when is the matrix singular? The matrix would be singular when the determinant, or as you can see from this symbol, the determinant of A is equal to 0. And it would be non-singular when the determinant is not equal to 0. So in other words, it can be any other number but 0. So another thing that we will be learning in a later lesson is the inverse of a matrix. But just for context, in this scenario, a matrix that is singular does not have an inverse. So a singular matrix does not have an inverse. So if I was to tell you that I have a matrix that does not have an inverse, that's another way of me saying that a matrix is singular. So obviously a matrix that is non-singular is a matrix that has an inverse. Alright, so let's look at this first example here. Matrix S below is a 2 by 2 matrix with a determinant equal to 0. So we are saying here that the determinant of S is equal to 0. In other words, this is a singular matrix. Now, remember what we said about the determinant? We do the crisscross, so 3 times x take away 6 times 2. So the determinant of S would be equal to 3 times x. Remember our brackets, minus 6 times 2. We explored the importance of the brackets in our previous video. Make sure you check it out. It's very important. So 3 times x is 3x minus 6 times 2, which is 12. Now this here is an expression for this determinant of S, but we said that the determinant of S is equal to 0. So therefore we can say if this 3x take away 12 represents the determinant of S, and this is also the determinant of S, which is equal to 0, that means 3x minus 12 is also equal to 0. Remember, what we're trying to do here is determine the value of x. So in order to determine the value of x, we need to get x by itself. So in this case, if I want to get rid of the minus 12, to balance this equation, I have to add 12 to both sides. So if I add 12 here and add 12 here, this negative 12 plus 12 is going to cancel out. It's going to leave us with 3x, which is equal to 0 plus 12, which is 12. Another way of thinking of this is if we bring the negative 12 over to the other side of the equal side, it will turn to plus 12. Therefore, that's why I have 3x is equal to 12. Now to get x by itself, I have to divide both sides by 3 to get x by itself. So when I divide this side by 3, x will be by itself, and then 12 divided by 3 would give me 4. So therefore, x is equal to 4. So my final answer is x is equal to 4. And if we just run it through just to back check this, you'll end up with s is equal to, you have a 3 here, 6 here, a 2 here. Now we know what x is. So x is 4. Let's put that here. Now if I have to find the determinant of this, it would be 3 times 4 take away 6 times 2. So 3 times 4, remember our brackets, minus 6 times 2. I'm calculating the determinant of S, which is written like this and can also be written like this. So I can say here that 3 times 4 is 12 minus 6 times 2, which is also 12. What is 12 take away 12? 12 take away 12 is 0. Now remember from our previous video, once we get 0, this means that the matrix is singular because the determinant is equal to 0. So based on this, we can see that we are indeed correct with our answer here. Alright, so in this case now it's telling us that matrix T below is a singular matrix, a singular 2 by 2 matrix. We have to determine the value of x. So if this is a singular matrix, we know that the determinant, again, in this case is equal to 0. So this is another way of saying that the determinant is equal to 0. So we do our crisscross, what we like to do. So we have 4 times x minus 8 times minus 5. So 4 multiplied by x, remember our brackets, take away 8 times negative 5. So what we'll end up with is 4 times x is 4x minus 8 times negative 5. Now a positive, this is a positive value, times a negative value is equal to a negative value. Therefore, we will get negative, then 8 times 5 is 40. So essentially, positive 8 times negative 5 would give us negative 40, because a positive times a negative equals a negative. So then we'll have 4x, and because we have this minus minus, this minus minus will turn to a plus. So we have 4x plus 40. So this here is the determinant of t. Now remember, we have to calculate the value of x. We also know that this matrix T is singular, which means its determinant is equal to 0. So therefore, if the determinant is equal to 0 and this determinant is equal to 4x plus 40, that must mean that both of them are equal to each other. So in other words, 4x plus 40 must be equal to 0. Now think of it like this: if we want to get the x by itself, we have to get rid of this 40 first. So if we bring this 40 over, it would turn to minus 40. Okay, so we'll end up with this going over the equal sign. So because it's a plus 40, when it comes over here, it'll turn to minus 40. So then we'll have 4x is equal to negative 40. Some people like to look at it as subtracting 40 from both sides, doing the opposite from both sides, whichever one makes you comfortable. So basically 40 take away 40, this would cancel. Over here we'd have 0 take away 40, which is negative 40. So whichever one you prefer, you use. So what matters here now is that we are left with 4x is equal to negative 40. So now we have to divide both sides by 4 to get x by itself. So if I divide negative 40 by 4, I'll be left with negative 10. Why negative 10? Because a negative divided by a positive is a negative. So therefore, x would be equal to negative 10. So that's our answer. And if you want, you could work it back out to prove the point. So we go to our example 3 now, which says calculate the value of m if matrix E is non-singular and has a determinant of 8. So in this case, we're saying that the determinant is equal to 8. So we do all the regular thing, crisscross. So 17 times 4, then negative 5m times 2. So once we do that, we know that the determinant of E can be represented as 17 times 4. Remember our brackets. Take away negative 5m times 2. So what's 17 times 4? 17 times 4 would give us 68. Then we'll end up with 68 minus, now negative 5m times 2. We have a negative here times a positive value. So negative 5m times positive 2 would give us a negative. So we have here negative, then 5 times 2 is what? 10. So we have negative 5m times 2, which gives us negative 10m. So we can simplify this and say 68, and this minus and minus turns to plus. So you have 68 plus 10m. So that's an expression for the determinant. Now remember, we said that the determinant here is 68 plus 10m, but it's also equal to 8. Therefore, we can say that 68 plus 10m is equal to 8. The thing is, we need to get 10m by itself. So we have here the 68, which is a positive value here. So if it goes on the next side of the equal sign, it's going to turn to what? A negative value. Okay, so then we'll be left on this side with 10m, which is equal to 8 minus 68. Okay, so it's the same concept. I'm just doing a shortcut of it. So the opposite of having 68 would be subtracting 68. If I do it over here, it would be the same thing, just to keep the balance. So that's why you would see that these two would cancel out, and I'll be left with 10m, which I have here, which is equal to 8 take away 68. Now we can simplify this. So we'll have 10m, and now if I'm saying 8 take away 68, that would leave me with negative 60. So 8 take away 68 is negative 60. So I can divide both sides by 10 now to get m by itself. So then I'll be left with m is equal to negative 60 divided by 10. So a negative divided by a positive gives us a negative. So therefore I'll have negative, and 60 divided by 10 is 6. So m is equal to negative 6. So if we was to try to work this back out, we know for sure that m is equal to negative 6. So this example says that matrix n has a determinant equal to 9. So we are saying that n, the determinant, is equal to 9. So this means it's non-singular. The fact that it is not equal to 0, we know it's a non-singular matrix. This is just for revision purposes. So we do our same thing. So x times x take away negative 10 times negative 4. What we would have is x multiplied by x. We still keep our brackets, very important, minus negative 10 times negative 4. Now, if you look at this, x times x is what? X times x is x squared. Then we have minus negative 10 times negative 4, which is positive 40. Now, how did I get positive 40? So I got positive 40 because a negative times a negative gives me a positive. So therefore, I can say that this one is x squared minus 40. Now, if we know that the determinant can be expressed this way and it's also equal to 9, that means these two must be equal to each other. So in other words, x squared minus 40 must be equal to 9. So let's just add 40 to both of them. In other words, we bring the negative 40 over the equal sign, which turns to positive 40. So these will cancel and we know we'll be left with x squared is equal to 9 plus 40. Now, what is 9 plus 40? That's 49. So x squared is equal to 49. Now, we are not quite complete with this question. We have x squared is equal to 49. So the question is, what is the opposite of squaring? The opposite of squaring is finding the square root. So we can find the square root of both sides, which means we'll be left with x is equal to the square root of 49. What is the square root of 49? 7. Now, not only is it 7, it can be 7, which is positive, or negative. So x can either be equal to 7 or x could be equal to negative 7. Why? Because positive 7 times positive 7 is 49, which we have here. And then negative 7 times negative 7 is also equal to 49. This is why we can have two answers. So therefore, the values for this question would be this, because we're looking for the value of x. So we're looking at this here now. It says matrix P does not have an inverse. Does not have an inverse. Now, the first thing we spoke about in the beginning of this video is that when a matrix does not have an inverse, that means that a matrix is singular. Now, if the matrix is singular, that also means that the matrix has a determinant that is equal to 0. So therefore, we know that the determinant of this matrix P is equal to 0. So this here is a fancy way of saying that the determinant is 0. Now, we have to find a determinant to work this out. So we do the same thing again, crisscross. So then we'll have 2r multiplied by r brackets, and we subtracting it with 8 times 4. Now, what is 2r times r? 2r times r is 2r squared. And then we're going to subtract 8 times 4. What is 8 times 4? 8 times 4 is 32. So we have it here. This is 2r squared minus 32. Now, we said that this here is equal to the determinant, which is an expression. And here, we also have the determinant equal to 0. Therefore, we can write our equation now and say 2r squared minus 32 must be equal to 0. Now we could solve. Now, the first thing we need to do is we need to get the 2r squared by itself. So if we was to bring this minus 32 over, it will turn to positive 32. So it's the same thing as adding 32 to both sides. So therefore, we'll have 2r squared. Now, since this cancels, because when we bring this over, it'll give us this minus 32 comes over and turns to positive 32. We'll be left with this. Now, if I'm looking at this, r is being squared and it's also being multiplied to the 2. So the first thing I want to get rid of is this 2 here. So I can isolate the r squared. So what is the 2 doing to the r squared? It's multiplying to the r squared. So I have to do the opposite, which is dividing. So I divide both sides again here by 2. So r squared would therefore equal to be 32 divided by 2, which is 16. Now, in order to figure out what r is, we need to do the opposite of squaring. What is the opposite of squaring? We did this in a previous question. We find the square root of both. That's the opposite procedure. So r therefore must be equal to the square root of 16, which is plus or minus 4. So therefore r can be equal to positive 4, or r can be equal to negative 4. Because remember, negative 4 times negative 4 is positive 16, and 4 times 4 is positive 16. So this is basically how we answer this question. This here was an example of how the determinant can be mixed with algebra to kind of really see if you understand the concepts and the theoretical aspect of matrices. So knowing what a singular matrix is, knowing what a non-singular matrix is, knowing what the values you get when those are singular or non-singular, and what you can do with them. Understanding what it means to not have an inverse, which means it's a singular matrix. And therefore, if it's a singular matrix, the determinant must be equal to 0. These are things that you have to make sure you understand coming up to your exam. So this is something you can go over at any time just to reinforce the concepts and get it down pat. Remember, maths is about practice. It's about consistency. The more you practice, the more you work on it, the more you stay consistent with it, the more you grow. You got to be at it. It's just like tying your shoes. Tie your shoes every single day until you become a pro. Now you can tie your shoes without thinking about it. With maths, you gotta practice. The more you practice, the better you're gonna get.